on its lateral edge, the tendon fans out. Here it is in the intact forearm, into a thin sheet of fascia, the bicipital aponeurosis, which becomes continuous with the deep fascia that surrounds the forearm. The aponeurosis gives the biceps an indirect attachment to the ulna. The biceps flexes the elbow. It does this more efficiently when the forearm is pronated, because then it's fully stretched when it starts its action. The biceps can also be a powerful supinator of the forearm, as we'll see later. The last of the three elbow flexors is brachioradialis. It arises halfway up the humerus, just below the deltoid tuberosity. It's inserted all the way down here on the distal radius. Brachioradialis is an efficient flexor of the elbow, whether the forearm is pronated or supinated. The action of the flexors is opposed by just one extensor muscle, the triceps. The triceps muscle has three heads: a long head, a lateral head, and a medial or deep head. The long head arises, as we saw in the last section, from the infraglenoid tubercle of the scapula. The lateral head arises high up on the lateral side of the posterior humerus. The medial head arises from a broad area lower down and more medially. As we'll see, the radial nerve runs next to the bone between the lateral and medial heads. The three heads of triceps converge to form this massive tendon, which inserts here on the olecranon. Contraction of the triceps extends the elbow. Just for completeness, we need to mention this tiny muscle, the anconeus. It runs from the lateral epicondyle to the lateral aspect of the proximal ulna. Anconeus is a very minor elbow extensor. Now let's look at the muscles that produce pronation and supination. There are two of each. Of the two pronator muscles, the larger and more proximal one is pronator teres. Along with several other muscles, it arises from the medial epicondyle. In addition, it has a small deep head of origin, which arises from this part of the ulna. Here's the deep head of pronator teres. The median nerve passes between the two heads of pronator teres as it enters the forearm. Pronator teres inserts here, halfway down the lateral surface of the radius. Here's its action: pronation. The second pronator muscle is pronator quadratus, which arises from the anteromedial aspect of the ulna and inserts here on the anterior surface of the radius. Here's the action of pronator quadratus. Now let's look at the two muscles which produce supination. The one that we haven't seen yet is simply called supinator. Here it is. It arises from the lateral epicondyle, from the annular ligament, and from this ridge on the ulna, the supinator crest. It's inserted on the radius along a line ending just above the insertion of pronator teres. The deep branch of the radial nerve runs through the supinator. It enters here and emerges under here. Here's the action of supinator. It's a nice match for pronator teres. The other supinator muscle we know about already. It's the biceps. The insertion of the biceps on the radial tuberosity gives it plenty of power to rotate the radius, especially when the elbow is flexed. When the biceps is working as a supinator, its flexing action is held in check by the simultaneous action of the triceps. Because of the great strength which biceps contributes, supination is a more powerful action than pronation. Now, let's look at the muscles which produce wrist movement. There are 3 flexors and 3 extensors. We'll look at the flexors first. The 2 important ones are flexor carpi radialis and flexor carpi ulnaris. They both arise from the medial epicondyle, where they share a massive tendon of origin, the common flexor tendon, with two other flexor muscles. In addition, flexor carpi ulnaris has an extensive ulnar head, which arises from this border of the ulna. The ulnar nerve, as we'll see, passes between the two heads of flexor carpi ulnaris as it enters the forearm. The two wrist flexors diverge to arrive at the radial and ulnar sides of the wrist. Flexor carpi radialis passes through a deep ligamentous tunnel and ends up inserting on the base of the second metacarpal. Flexor carpi ulnaris inserts on the pisiform bone. From the pisiform, the pull of flexor carpi ulnaris is transmitted to the hamate bone and to the base of the fifth metacarpal by these strong ligaments, the pisohamate and pisometacarpal ligaments. The two wrist flexors, acting together, produce flexion of the wrist. Acting separately, the ulnar and radial flexors contribute to ulnar abduction and radial abduction, respectively. Lying between these two main wrist flexors is a third small one, palmaris longus. It arises from the medial epicondyle like the other two. Its tendon, seen here in the intact forearm, lies superficial to all its neighbors and inserts not into bone, but into this dense layer of fascia, the palmar aponeurosis, which covers the palm of the hand. Through this soft tissue insertion, palmaris longus helps to flex the wrist. It's frequently absent. Now let's go around to the other side of the forearm and see the wrist extensors. Here they are, extensor carpi radialis longus and brevis, and extensor carpi ulnaris. Brachioradialis, which you'll remember goes from here to here, has been removed in this dissection. Extensor carpi radialis longus arises from the lateral epicondylar ridge just below brachioradialis. Extensor radialis brevis arises from the lateral epicondyle, an origin which it shares with several other extensor muscles. They all arise together from the epicondyle and from this common extensor tendon. Extensor carpi ulnaris arises from the lateral epicondyle. It also has an ulnar head, which arises from this border of the ulna. As the extensor tendons cross the back of the wrist, they pass under this structure, the extensor retinaculum, which acts as a pulley. Extensor carpi radialis longus and brevis are inserted on the bases of the second and third metacarpals. Extensor ulnaris on the base of the fifth metacarpal. When the wrist extensors act together, they extend the wrist. That's an important part of the action we make when we go to grip something. The powerful gripping muscles, whose tendons run over the front of the wrist, are slack and feeble when the wrist is flexed, but they become tight and powerful when it's extended. When the radial extensors or the ulnar extensor contract separately, they help to produce radial or ulnar abduction of the wrist. They do this in conjunction with the corresponding wrist flexor muscle, either radial or ulnar. It's good to study muscles function by function, as we've done so far in this section, but it's also important to see how they all overlap and fit together. If you'd like to use this next overview as a review section, turn off the sound. Let's look at a dissection that includes all the muscles that we've looked at so far in the arm and forearm and in the adjoining shoulder region. Here's the biceps with its two heads hidden both by the deltoid and pectoralis major. Here's the short head of biceps running close to coracobrachialis. Running up behind biceps and coracobrachialis is latissimus dorsi. Here's brachialis going to its insertion on the ulna, and here's biceps on its way to the radius. Here's pronator teres, crossing over from the medial epicondylar ridge to the radius. Also arising from the medial epicondyle, here are flexor carpi radialis, palmaris longus, and flexor carpi ulnaris. Here's pronator quadratus, deep to everything. Now let's go round and take a look at the back. Here's the triceps with its long head going up beneath the deltoid. Here's teres major, and here's latissimus dorsi again. Here's triceps going to its insertion on the olecranon. Here's brachioradialis, going to the radius here. Here's extensor carpi radialis longus and brevis, and extensor carpi ulnaris. Lying deep to all the muscles which share the common extensor tendon is supinator, all on its own. At this point, our picture of the forearm is complete as to some functions, incomplete as to others. That's the way we're going to leave it for now. We'll be returning to the forearm in the next section to look at the important muscles there that we've not seen yet, the long muscles of the fingers and of the thumb. Now, let's move on to look at the vessels and nerves of the region. We'll go from the shoulder to just below the elbow. First, we'll look at the veins. Many superficial veins from the forearm converge just below the elbow to form two large veins, the basilic and the cephalic. The cephalic vein stays at a superficial level as it runs up the arm over the biceps. At the top of the arm, it lies between the deltoid and pectoralis major. The large vein crossing the front of the elbow is the antecubital vein. It crosses from the cephalic to the basilic vein. The basilic vein then runs up the medial aspect of the arm to join this brachial vein, which is one of a pair. The two brachial veins join together as they pass up the arm. Here they are joining to become one brachial vein. The name of this vein then changes. Up here, it becomes the axillary vein. To get a good look at it proximally, we'll remove pectoralis major. Here's the axillary vein running alongside the median nerve and the axillary artery, and disappearing with them behind pectoralis minor. Now let's look at the artery and the principal nerves of the arm. From here on, the veins which run parallel to the arteries have been removed to simplify the picture. Here's the main artery, the axillary artery. It emerges from beneath pectoralis minor, surrounded by major nerves. As it passes into the arm, its name changes. From here on down, it's the brachial artery. Here, right next to the latissimus tendon, it gives off a large branch, the deep brachial or profunda brachii, which passes backward deep to the triceps. Along with it goes the radial nerve, which we'll see in a minute. The brachial artery runs down the medial side of the arm, alongside the brachialis muscle. The median nerve crosses over the artery. The brachial artery passes beneath the bicipital aponeurosis, which we'll remove. Alongside the biceps tendon, the brachial artery divides into the two major arteries of the forearm, the radial and the ulnar. The radial artery stays quite superficial. It runs down the forearm between pronator teres and brachioradialis. The ulnar artery has a much deeper course. It dives down alongside the brachialis tendon and passes deep to pronator teres. We'll leave the arteries there. We'll see their further course in the next section. Now we'll go back up to the top and look at the nerves. 4 nerves surround the axillary artery as it emerges from beneath pectoralis minor. They're the musculocutaneous, the median, the ulnar, and the radial. We'll look at them in that order. Here's the musculocutaneous nerve. It supplies 3 flexor muscles in the arm, the first of which is a shoulder flexor, coracobrachialis. The musculocutaneous nerve runs right through coracobrachialis and emerges here deep to the biceps. It runs down the arm between biceps and brachialis, supplying both muscles. It emerges here to become the lateral cutaneous nerve of the forearm. The median nerve and the ulnar nerve both run all the way down to the elbow without supplying anything. They start out close together. Halfway down the arm, they diverge. The median nerve stays close to the brachial artery, crossing in front of it. At the elbow, it lies medial to the artery. It dives down between the brachialis tendon and pronator teres and passes between the two heads of pronator teres to enter the forearm. The ulnar nerve slants backwards. It runs down just medial to the triceps tendon and behind the medial epicondyle. It turns a sharp corner round the underside of the medial epicondyle, where there's a fibrous tunnel for it. It passes between the two heads of flexor carpi ulnaris to enter the forearm. Once they get below the elbow, the median and ulnar nerves get busy. Between them, they supply all the flexor and pronator muscles of the forearm. Of the muscles that we've seen already, the median nerve supplies 4: pronator teres, flexor carpi radialis, palmaris longus, and pronator quadratus. The ulnar nerve supplies 1 muscle that we've seen so far, flexor carpi ulnaris. Lastly, let's look at the radial nerve. It has a long spiral course from here round to here. Up here, the radial nerve lies behind all the other nerves and vessels. Just below the latissimus tendon, it runs back between the long head and medial head of triceps. To follow its course, we need to go right round to the back and find the same spot again from behind. Here's the long head of triceps, here's the medial head, and here's the radial nerve. To see where it goes next, we'll remove the long head of triceps. As the radial nerve passes round the humerus, it lies right on the bone. It runs between the medial and lateral heads of triceps, then runs beneath the lateral head to emerge here, still right on the bone, just above brachia radialis. Under cover of brachia radialis, it reaches the lateral epicondyle, where it divides into a deep or motor branch and a superficial or sensory branch. That's as far as we'll follow the radial nerve for now. Of the muscles that we've seen, the radial nerve supplies the triceps, anconeus, brachia radialis, all 3 wrist extensors, and supinator. To end this section, let's briefly review first the vessels and then the nerves from the shoulder to the elbow. Here's the cephalic vein and the basilic vein, the antecubital vein, the brachial vein, and the axillary vein. Here's the axillary artery, the brachial artery, the profunda brachii artery. At the elbow, the radial artery and the ulnar artery. Now the nerves. Here's the musculocutaneous nerve, the median nerve, the ulnar nerve, and the radial nerve, with its superficial branch and its deep branch. That brings us to the end of this section. In the next section, we'll move on to look at what the upper extremity is all about, the hand. To understand the hand, we'll begin by looking at the bones and joints. Then we'll look at some important pulleys, and then we'll see the muscles. After that, we'll add the vessels and nerves, and lastly, we'll look at the skin. The terms that we'll use for orientation are ulnar and radial for the sides of the hand, radial being the side with the thumb, and palmar and dorsal for the front and the back. To begin looking at the bones and joints of the hand, let's see what they're called. Here are the 8 carpal bones, and here are the 5 metacarpals. Each finger has a proximal phalanx, a middle phalanx, and a distal phalanx. The thumb just has 2 phalanges, a proximal phalanx and a distal phalanx. The joints of the hand have long names. The joints between the carpus and the metacarpals are the carpo-metacarpal joints. The joints between the metacarpals and the proximal phalanges are the metacarpophalangeal joints. The joints between the phalanges are the interphalangeal joints, proximal and distal. We'll often refer to these joints as CMC joints, MP joints, and IP joints for short. To look in some detail at the bones and joints of the hand, we'll look first at the carpus, then at the 4 fingers with their metacarpals, then at the thumb with its metacarpal. We saw the individual names of the carpal bones in the previous section. Let's look at their overall shape. There are 2 bony projections on each side. On the ulnar side, the pisiform bone, and this part of the hamate, called the hook. On the radial side, the tubercle of the scaphoid, and the crest of the trapezium. With these projections, the bones of the carpus form the base and the side walls of a space called the carpal tunnel. Here's how the carpus looks in the living body. The radiocarpal and midcarpal joints are hidden by the heavy capsular ligaments. Here are those 4 projections again: the tubercle of the scaphoid, the crest of the trapezium, the pisiform, and the hook of the hamate. And here's the carpal tunnel, still without its roof. Now let's move on to look at the metacarpals of the 4 fingers and at their CMC joints. Here are the carpo-metacarpal joints. The bases of the 4 finger metacarpals, tightly packed together, articulate here with the distal row of carpal bones. The base of the first metacarpal, the one for the thumb, articulates separately here with the trapezium. These 4 carpo-metacarpal joints only allow a small amount of movement. The 5th metacarpal is the most mobile, the 4th is less so, the 3rd hardly moves at all, and neither does the 2nd. When the CMC joints are flexed, the metacarpal heads lie in a curve. This strong ligament is the deep transverse metacarpal ligament. It keeps the metacarpal heads of the 4 fingers from spreading apart. As it crosses each MP joint, the ligament is continuous with a structure that we'll meet shortly, the palmar plate. Since it doesn't connect to the first metacarpal, the ligament doesn't prevent movement of the thumb away from the hand. Next, we'll move on to the bones and joints of the fingers themselves. The proximal and middle phalanges are flattened on their flexor aspects. The flexor tendons run along here. The sheath that surrounds the flexor tendons is attached to these ridges. The tip of the distal phalanx is flattened. The fibrous pulp of the fingertip is attached here. The bed of the fingernail is attached here. Now let's look at the metacarpophalangeal joint, the MP joint. It's the joint at which the finger becomes separate from the hand. We'll take the other fingers away so that we can see it from all sides. The articular surface of the metacarpal head is curved in 2 planes, from side to side and from front to back. The base of the proximal phalanx has a concave articular surface that's also curved in 2 planes. The shape of the bones allows a wide range of flexion and extension at the MP joints. It also allows a range of side-to-side movement that's greater when the joints are extended, less when they're flexed. We'll see why that is in a minute. Let's see what the joint looks like in the living body. The MP joint has a capsule that's loose on the back to allow the joint to flex. On the front, the capsule thickens remarkably into a tough piece of fibrocartilage, the palmar plate, also called the palmar ligament. The palmar plate moves along with the proximal phalanx when the joint flexes. Here's the palmar plate incised to show how thick it is. As we'll see, some important structures are attached to the palmar plate, or merge with it. One of them we've seen already, the deep transverse metacarpal ligament. It goes here. Here, we've removed most of the joint capsule so that we can see the two massive collateral ligaments which hold the MP joint together. The collateral ligaments run obliquely from the back of the metacarpal head to the front of the base of the proximal phalanx. The collateral ligaments are loose when the joint is extended, but when it's flexed, they become tight. So when the joint is extended, side-to-side movement can occur readily, but when the joint is flexed, the tightness of the ligaments prevents side-to-side movement. We need to understand the names that are given to those side-to-side movements at the MP joints. Spreading all the fingers apart is called abduction. Bringing them all together is adduction. Those are useful terms for describing those collective movements of the fingers. But when we're speaking of an individual finger, it's often simpler to speak instead of ulnar deviation and radial deviation. Now let's move on to the interphalangeal joints. The proximal and distal IP joints are very much alike. They're different from the MP joints in that they only allow flexion and extension. The head of the phalanx is curved mainly from front to back, with a slight depression in the middle. The base of the adjoining phalanx has a corresponding curve to it. The capsule of an IP joint is much like that of an MP joint. But the collateral ligaments are different in that they're equally tight in flexion and in extension. Now let's move on from the fingers to look at the bones and joints of the thumb. The first carpo-metacarpal joint is the joint which gives the thumb its special position and a great deal of its special mobility. Let's take off the metacarpal heads to see the joint surfaces. Here's the first CMC joint. It sits in front of these other CMC joints and at an angle to them.